Welcome to The Explainer. Today, we're diving into an absolutely incredible technological leap that's happening right now in East Africa. If you look at the rapid digital transformation sweeping across Kenya, it's essentially turned into this booming, neon-lit frontier of innovation. We're talking massive mobile money networks, cloud computing, digital identity platforms, and the Internet of Things, literally revolutionizing how people live and work. But there's a catch. All of this amazing digital progress has accidentally blown the doors wide open, massively expanding the cyber threat landscape. So to survive, this booming digital megacity urgently needs something new. It needs an advanced AI-driven digital nervous system.
Okay, let's quickly run through our boot sequence for today. We'll start with Kenya's digital boom and the new threats it brings. Then we'll get into the core AI cybersecurity upgrade, look at how it speeds up incident response, explore how it's protecting critical Kenyan sectors, and finally, wrap up with open source tools and the ethics of it all. Let's get into it.
Section 1. Kenya's digital boom and the threat.
So, as we just established, innovations like online government platforms and mobile money have totally transformed accessibility in Kenya. But naturally, they've also created a very lucrative target for malicious actors. Now, to really grasp the solution, we kind of have to look at why the old way of doing things is failing. Traditional security, it's basically like building a giant stone wall around your city. It relies on firewalls and antivirus software that compare network activity against known attack signatures, meaning it's completely reactive. If it hasn't seen a specific attack before, well, it has no idea how to stop it. AI security, on the other hand, is more like a living, breathing defense system. It's continuously analyzing huge volumes of data, finding hidden relationships, and proactively predicting potential attacks. It doesn't sit around waiting for a breach, it anticipates it. And as you can see here, because the attack surface is expanding so fast, taking a proactive approach isn't just nice to have anymore, it's absolutely mandatory. Cybercriminals aren't just deploying basic, everyday viruses. They are using highly sophisticated tactics, ransomware, zero-day exploits, and get this, even their own AI-assisted attacks. The old-school method of relying on a checklist of predefined rules, it just can't keep up with threats that evolve this quickly in real time.
Moving on to Section 2, the AI cybersecurity upgrade.
To actually fight back against these advanced threats, organizations are having to fundamentally upgrade the central nervous systems of their security operations centers, or SOCs. And the real game changer here is the AI-driven SIEM, that's Security Information and Event Management. You see, traditional SIEMs had this huge problem where they generated an overwhelming number of false positives. It caused massive alert fatigue for the human analysts. But the AI upgrade fixes this through something called anomaly detection. Instead of just hunting for known bad guys, anomaly detection is all about learning what normal behavior looks like and then flagging any weird deviations from that baseline. The machine learning algorithms digest millions of daily security logs to understand legitimate user behavior, which makes them incredibly good at spotting when something is just off.
Now, what's really fascinating is how these specific behavioral deviations instantly trigger the AI's predictive intelligence. Like, imagine a user fails to log in 5 times and then suddenly succeeds? Boom, flagged. Someone is accessing highly sensitive systems at 3 a.m.? Flagged. If there's an unexpected spike in massive outbound network traffic, or an unauthorized privilege escalation, or an employee randomly digging into confidential data that has nothing to do with their job, all of it gets flagged immediately. A traditional system might totally miss those contextual clues, but the AI catches them because it knows they break from the normal baseline.
So how does the AI actually figure all this out? Well, it's basically a tag team of different machine learning models under the hood. First, you've got unsupervised learning, which is absolutely brilliant at identifying totally unknown zero-day attacks without even needing labeled data. Then you have supervised learning models, which are heavily trained on historical incident data so they can instantly spot those known attack patterns. And finally, you have deep learning. This is the real heavy lifter. It recognizes highly complex hidden behavioral relationships that a human eye or a conventional tool would be completely blind to.
Let's actually look at how this plays out in the real world. Check out this exact timeline. Okay, at 14:00, 2 p.m., an employee logs into the system from Nairobi during regular working hours. Totally normal, the AI baseline accepts it. But then, at exactly midnight, there's a sudden login attempt from a foreign country trying to access sensitive databases. Boom! In literally 1 second, the AI-driven SIEM triggers a high-risk anomaly and slaps a dynamic risk score on it. By second 2, just 2 seconds in, the system has already automatically correlated this event with previous authentication failures and hands the security team a fully contextualized threat alert on a silver platter.
Which brings us right into Section 3, speeding up incident response. In cybersecurity, speed is literally everything. Industry studies consistently show that organizations that can detect and contain threats quickly suffer way lower financial and operational hits. To get that kind of lightning-fast speed, AI integrates with SOAR technologies. That stands for Security Orchestration, Automation, and Response. The absolutely crucial takeaway here is that this automation drops response times from hours down to mere seconds. When a threat is confirmed, the AI can instantly isolate a compromised endpoint, block a bad IP address, disable a hacked account, quarantine a suspicious file, and even start collecting forensic evidence. All of this predefined containment happens on autopilot, which completely frees up your human security pros to focus on the high-value investigative work rather than getting bogged down in repetitive operational tasks.
Section 4. Protecting critical Kenyan sectors.
Let's ground all these high-tech concepts on the actual front lines and see how this digital armor is protecting the core pillars of the Kenyan economy. First up, financial services and mobile money. As we know, Kenya runs one of the world's leading digital financial ecosystems. We are talking millions of transactions every single day. AI is protecting this massive target by using behavioral analytics to catch things like SIM swap fraud, identity theft, and those really complex social engineering attacks, all before the money ever actually leaves the bank.
Next, we've got government digital services. With the government pushing tax services, licensing, and public records online, they're handling incredibly sensitive citizen data. AI steps in here to provide the continuous, 24/7 monitoring needed to catch insider threats, track what privileged users are doing, and stop data exfiltration dead in its tracks.
Over in healthcare, the stakes are, no exaggeration, life or death. Hospitals are leaning heavily on electronic medical records and all sorts of interconnected medical devices. AI is absolutely critical here to spot early signs of ransomware and shut down weird system behaviors before a hospital's critical services or telemedicine platforms get taken offline.
Then there's telecommunications. Kenya operates some of the absolute largest mobile networks in Africa. These telecom operators rely massively on continuous AI behavioral analysis to swat away huge distributed denial of service, or DDoS attacks, along with signaling attacks and network intrusions that could literally bring down the grid.
And finally, education. Universities that use cloud-based learning platforms are tapping into machine learning to sniff out highly specialized phishing campaigns aimed at their students, and to stop malware from compromising important academic resources.
All right, rounding it out with Section 5, Open Source Tools and Ethics.
Now, you might be sitting there thinking, okay, deploying this cyberpunk-level AI tech must require a massive bottomless budget, right? Actually, no. Open source tools are completely democratizing this space. Just look at this lineup. Platforms like Wazoo give you true enterprise-grade CM and extended detection capabilities. SecurityOnion is an absolute powerhouse for network monitoring and forensics. Suricata is your go-to high-performance intrusion prevention engine. Zeek is this incredible framework that strictly focuses on behavioral monitoring instead of those outdated signatures. And the Elk Stack is pretty much the industry standard for centralized log collection. These open-source tools mean organizations across Kenya, even those with tighter budgets, can spin up world-class, locally trained security platforms.
But developing these customized models requires a lot of responsibility. Cybersecurity researchers are leveraging powerful Python libraries, things like TensorFlow, PyTorch, and scikit-learn, to build tailored threat detection models that actually fit the specific local operational environments of East Africa. But getting this right, it requires a really hard look at the ethical mandate of how these systems operate in the real world. Because when we talk about responsible AI implementation, it really boils down to everyday, practical realities. Organizations absolutely must minimize unnecessary data collection and strictly follow legislation, like Kenya's Data Protection Act of 2019. It's also about building good, fair models. Actually, if an AI is poorly trained on incomplete data, it might start incorrectly blocking totally legitimate users, or worse, miss a massive network threat entirely due to algorithmic bias. You also need total transparency in how the AI makes its decisions, especially when those automated actions affect employees or customers. And most importantly, and this is key, AI is built to augment, not replace, human professionals. Expert analysts are still absolutely vital to validate what the AI recommends and to make the final strategic calls. Which leaves us with this final, kind of provocative thought.
AI and machine learning are fundamentally transforming how organizations in Kenya, and honestly around the globe, shift from reactive defense to proactive threat hunting. But as AI continues to evolve into this ultimate automated defender, capable of spotting invisible threats and locking down networks in literal seconds, will the human analyst ultimately become the most vulnerable link in the chain, or will they become the most vital overseer, ensuring our digital future stays secure, ethical, and entirely human-led? It's definitely something to think about as you navigate the future of cybersecurity. Thanks so much for joining me for this explainer. Keep learning and stay secure out there.